Why has no country dared to build a nuclear-powered aircraft? When mentioning nuclear energy, what comes to mind? If it's nuclear-powered submarines or aircraft carriers, you're undoubtedly a true fan of powerful weaponry. Unlike conventional fuel submarines that must frequently surface for refueling, nuclear submarines can operate at high speeds underwater for decades without interruption. According to design schematics and expert calculations, the latest version of Ohio-class submarines can continuously operate for about half a century. Whereas the USS Nautilus, which entered service in 1954, needed refueling every 2 years. The advantages of nuclear power are clear. So why not create an aircraft powered by highly enriched nuclear fuel for extended operational times? Many of you might immediately think of the dangers of radiation exposure. Nuclear energy often emits harmful random radiation. Although the fission process releases controlled radiation within a nuclear reactor, if safety measures are inadequate, radiation could leak into the environment, leading to severe consequences for humans. However, you might be surprised that safety concerns for the pilots aren't the primary reason. The main challenge is creating a nuclear engine light enough to fit onto an aircraft. Then comes the challenge of shielding pilots from the harmful radiation emitted by a nuclear engine positioned right behind them on the aircraft. But that didn't stop the US and the Soviet Union from exploring the concept during the Cold War. With the rising threat of nuclear war in the mid-20th century, American engineers devised some incredibly bold plans. One was to build a nuclear-powered aircraft and recruit retired, older pilots, reasoning that they would pass away from natural causes before radiation exposure could lead to cancer. This somewhat inhumane project was proposed by none other than Enrico Fermi, the father of the nuclear era, while working on the Manhattan Project, which resulted in 2 atomic bombs being dropped on Japan. Fermi envisioned flights powered by enriched nuclear fuel rods. After World War II ended, the US began moving forward with its nuclear aircraft project. From 1946 to 1961, teams of engineers and strategists created numerous design blueprints to turn the concept into reality. As you might expect, the advantages of using nuclear energy for aircraft are similar to those for nuclear submarines. In 1945, the U.S. War Department, later renamed the Department of Defense, noted, with radioactive-powered aircraft, supersonic flights around the world will become practical. In a top-secret document from that era by the U.S. Atomic Energy Commission, now stored at the Eisenhower Presidential Library, it was stated that nuclear energy could allow aircraft to circle the Earth 1 or more times before needing to land to replace the fuel rods inside the engine reactor. For nuclear aircraft, they would only need to land because pilots were exhausted after long, intense hours of flight, not for refueling. Indeed, during the Cold War, refueling concerns were a significant issue for superpowers. Bomber planes consumed substantial fuel just to reach target locations. And after completing their missions, they had minimal fuel left for the return journey. Mid-air refueling was a solution. But it wasn't as ideal as some might think, especially when refueling over another country's airspace. Air defense systems would quickly target these aircraft, and both refueling planes would have to evade fighter jets and ground-based air defense systems. Aerial refueling often didn't work as planned and could even jeopardize the original mission. To minimize the need for mid-air refueling, the US had to buy or lease an entire network of airbases worldwide. These bases were often located near Soviet territory, allowing bombers to fly the shortest possible distance to their targets. However, this solution was costly. At one point, the US was even ready to offer $100 million in gold to buy Greenland from Denmark for establishing an American military base. Imagine calculating $100 million in Vietnamese currency. That's a huge amount. But surprisingly, the Danes coldly declined this lucrative offer. As you may know, A single nuclear-powered aircraft could solve all range limitations. But that doesn't mean engineers didn't face major obstacles that caused them sleepless nights. First, for the aircraft to fly, the onboard nuclear reactor had to be significantly smaller than a submarine reactor, yet produce more heat than usual to operate efficiently. Excessive heat could lead to a meltdown, potentially turning the aircraft into a giant radioactive mass hurtling toward Earth. The second issue was how to shield pilots from dangerous radiation emitted by the reactor. In nuclear power plants or submarine reactors, thick concrete walls enclose the reactor. But this isn't feasible on an aircraft. Lead shielding is usually effective, but it would make the plane too heavy, which isn't ideal for fighter jets that need to be lightweight for agility. Engineers theorized that the absence of a traditional fuel tank could allow for additional nuclear shielding. But after 16 years, the US couldn't make it work. The Soviet Union faced similar problems. Additionally, varying quality in nuclear fuel production across countries at the time made it difficult to control the reaction process effectively. With so many challenges, you might wonder how anyone could build a nuclear-powered aircraft. However, an article in Aviation Week reported that the Soviet Union was testing its first nuclear aircraft. President Eisenhower was quick to calmly dismiss the article as inaccurate for national image reasons. Why? A Soviet engineer from the nuclear aircraft program later explained, "If we had such a functioning aircraft, why wouldn't we proudly showcase it to the world instead of keeping it a secret?" It does seem logical. But perhaps the article was right. Because the Soviet Union did modify a Tu-95 bomber, fitting it with a nuclear-powered engine. A fact hard to hide from watchful eyes near the Kremlin. From May to August, the nuclear-powered Tu-95 LEL carried out 34 test flights with pilots, designers, and engineers on board. The tests showed promising performance. But there were still major issues, such as the aircraft's excessive weight and non-ideal flight endurance, especially how to protect the crew's health. Ultimately, like other experimental aircraft, the nuclear-powered Tu-95 LEL was put into storage and transferred to the Irkutsk Aviation Technical Institute in the early 1970s. After the reactor was removed, it served as a training aircraft. You might think the Soviet Union was the only country daring enough to conduct such experiments. But no, the US was actually ahead. In fact, as early as 1955, the US developed a nuclear-powered bomber prototype, the Convair NB-36 Crusader. This bomber carried a cooled nuclear reactor generating 1 megawatt of electricity, suspended inside the bomb bay and capable of being lowered via bomb bay doors. Equipped with secure shielding between flights. In theory, a nuclear-powered bomber could stay in the air for weeks at a time, reaching any target on the planet without the need to land or refuel. Keeping a plane in the sky for weeks might seem unnecessary. But this shouldn't be underestimated. During the Cold War, from 1960 to 1968, the US kept 3 B-52 bombers equipped with nuclear power on 24-hour alert, flying over the Atlantic, the Mediterranean, and the Pacific near Alaska. During the early 1950s, a bomber with minimal logistical support and the capability to remain airborne indefinitely seemed like the perfect gamble. But do you know what the common denominator was between the nuclear aircraft projects of these two rival superpowers? Neither nation could overcome the challenge of pilot protection and weight optimization for the aircraft. Furthermore, with the advent of intercontinental ballistic missiles, ICBMs, in the mid-1950s, the need for manned, nuclear-powered flights diminished significantly. These ICBMs, capable of traveling over 5.500 kilometers and designed to carry multiple nuclear warheads, were positioned on submarines and ground bases, poised as the most destructive forces in the event of an all-out nuclear war. Unlike shorter-range tactical missiles, under 300 kilometers, or intermediate-range ballistic missiles, up to 5.000 kilometers. ICBMs boast higher speeds and extended ranges, making them exceptionally lethal. Their mission was straightforward: destroy the target with no need for a return, sparing any concerns about shielding a human pilot from radiation. This tactical shift made the benefits of ICBMs quite compelling from a military perspective. The nuclear aircraft project gradually faded. By the late 1950s, President Eisenhower's administration slashed funding, and Nikita Khrushchev in the Soviet Union took similar measures. By 1961, both the US and the USSR had abandoned their nuclear aircraft development projects. However, the story didn't end there. In a final attempt to make nuclear aircraft feasible, strategists proposed using older pilots. These veteran pilots, unlikely to live long enough to experience the full effects of radiation exposure, could theoretically fly without the need for heavy radiation shielding. While this solution might have seemed practical, it was highly inhumane and wasn't enough to salvage the nuclear aircraft program. The US government deemed the project unnecessary, extremely dangerous, and prohibitively costly. On March 28, 1961, President John F. Kennedy officially canceled the program. Since then, occasional ideas for nuclear-powered aircraft have surfaced, but they have all been largely dismissed. Today, although air power remains a core component of warfare, the role of nuclear-powered aircraft is no longer a pressing concern. However, if the US, Russia, China, or another nation were to succeed in creating a nuclear-powered fighter jet, how do you think it would reshape the battlefield? Feel free to share your thoughts in the comments below. And don't forget to subscribe to our channel to join us on more exciting journeys. Thanks for watching, and see you next time.